Hello students, myself Yogesh Kashyap, lecturer mathematics from Government Polytechnic College for Girls, Patiala. Today's topic is transformation of sum or differences into product. We know that sine of A plus B is sine of A cos of B plus cos of A sine of B, and sine of A minus B is sine of A cos of B minus cos of A sine of B. Similarly, for cos of A plus B is cos of A cos of B plus sine of A sine of B, and cos of A minus B is cos of A cos of B minus sine of A sine of B. Now, if we add first and second equation, adding first and second equations, we have sine of A plus B plus sine of A minus B on the left hand side, and on the right hand side this cos A sin B will get cancelled with this cos A sin B, and we have simply 2 sin A cos B. Let us name this equation equation number 5. Now, if we subtract 2 from 1, we have sine of A plus B minus sine of A minus B on the left hand side, and on the right hand side this sine A cos B will get cancelled, this sine A cos B, and we have 2 times cos of A sine of B. Let this equation be number 6. Now see, if we add third and fourth equation, what will be we get? We get by adding 3 and 4, on the left hand side we have cos A plus B plus cos A minus B, cos A plus B plus cos A minus B. This sin A sin B will get cancelled, this sin A with this sin B, and we have 2 times cos of A cos of B. So, this is 2 times cos of A cos of B. Now, let this be equation number 7. Now, if we subtract this 4, if we subtract equation 3 from equation 4, what will we get? Cos of A minus B minus cos of A plus B. This is cos of A minus B minus cos of A plus B. You will get only 2 times sin A sin B, 2 times sin A sin B. Right? Now, if we substitute A plus B is equal to C and A minus B is equal to D. Now using both these equation, A plus B equal to C and A minus B equal to D, what will we get? We get value of C, which is A plus, sorry, we will from this value of C is, sorry, value of A is C plus D by 2. So, value of A is from this and this. If you add these two equations, A plus B equal to C and A minus B equal to D, value of A is C plus D by 2. Similarly, value of B is C minus D by 2, right. Now, substitute these values of A and B into equations 4, 5, 6, 7, sorry, yes, and 8, not 4, 5, 6, 7 and 8. Equation 5 is, this is sin A plus B plus sin A minus B, and equation 6 is sin A plus B minus sin A minus B equal to 2 cos A sin B. Let's substitute values of A and B, which is C plus D by 2, B is C minus D by 2. What we will get? We will get a formula to transform sum or differences into product. First one is, when you substitute value of A and B in the equation number 5, you will get sin C plus sin D is equal to 2 sin C plus D by 2 cos C minus D by 2. This is from equation number 5. Now, if you substitute value of A and B in the equation number 6, you will get sin C minus sin D is equal to 2 cos C plus D by 2 sin C minus D by 2. Similarly, if you substitute value of A and B in the equation number 7, you will get cos C plus cos D is equal to 2 cos C plus D by 2 cos C minus D by 2, and in last, when you substitute this value of A and B in the equation number 8, you will get cos of D minus cos of C is equal to 2 sin C plus D by 2 sin C minus D by 2, or this equation you can write it as, by taking minus common, cos C minus cos D is equal to minus 2 sin C plus D by 2 sin C minus D by 2, or you can adjust this minus sign with the within the angle 2 sin C plus D by 2 sin D minus C by 2. Hence, these 4 formulas are available for us to transform sum into product or differences into product. Formulate to transform sum or differences into product. So we have 4 formulas to transfer sum or difference into product. Let's repeat these formulas. First is sine of C plus sine of D. This is 2 sine C plus D by 2 cos C minus D by 2. This is your first. Now second, for differences, sine C minus sine D, 2 cos C plus D by 2 sine C minus D by 2. Third one is cos C minus cos D is equal to 2 cos C plus D by 2 cos C minus D by 2. And last one is cos of C plus D. This is for cos of C plus cos of D. Cos of C minus cos of D is equal to 2 sine C plus D by 2 sine D minus. So these are 4 formulae to transform sum or differences of sine, these two sine or cos T ratios, sum or differences into product. Let's try some example on this formula. Based on these formulas, let's first solve for express each of following into product. We have some sum or differences. We have to transform these sum or differences into product. First one is sine of 4 theta plus sine of 2 theta. Second one is sine of 6 theta minus sine of 2 theta. Third one is cos of 4 theta plus cos of 8 theta. And last one is cos of 6 theta minus cos of 8 theta. Let's try first part. First part, sine of 4 theta plus sine of 2 theta. Now this is of the form sine C plus sine D. Now you know this is 2 sine C plus D by 2 cos C minus D. So this is 2 sine C is 4 theta, D is 2 theta. So 4 theta plus 2 theta by 2 and cos 4 theta minus 2 theta by 2. So this is 4 theta plus 2 theta by 2 means simply 3 theta, and this is cos of theta. Now second case, sine of 6 theta minus sine of 2 theta. This is of type sine C minus sine D. Now we know that this is 2 cos C plus D by 2 sine C minus D by 2. So this is 2 sine 6 theta 2 cos 6 theta plus 2 theta by 2 sin 6 theta minus 2 theta by 2. So 6 theta plus 2 theta is 8 theta. So it is cos 4 theta, 6 theta minus 2 theta, 4 theta. So this is sin 2 theta. And third one is cos of 4 theta plus cos of 8 theta. This is of type cos C plus cos D, and we know that cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2. So this is cos of 2 times cos of 4 theta plus 8 theta by 2 cos of 4 theta minus 8 theta by 2, and you know this is 8 theta plus 4 theta is 12 theta and divided by 2. So it is cos of 6 theta, and here you see cos of 4 theta minus 8 theta, which is minus 4 theta. So it is cos of minus 4 theta by 2, which is minus 2 theta, and since we know that cos of minus theta is cos theta, and this, as this is an example of even function, so this is 2 cos 6 theta and cos of 2 theta. And last one is this one, cos of 6 theta minus cos of 8 theta. This is of the type cos C minus cos D, cos C minus cos D, and you know that cos of 6 theta minus cos of 8 theta, this is cos C minus cos D, 2 sin C plus D by 2 sin D minus C by 2. So this is 2 sin 6 theta plus 8 theta by 2, and sin, here is D minus C. Note this step, it is sin D minus C by 2. So this is 2 sin 7 theta, and this is simply sin theta. Let's try another example. Show that cos of 18 degree minus sine of 18 degree is equal to 2 times sine of 27 degree. So here example is cos of 18 degree minus sine of 18 degree is equal to 2 times sine of 27 degree. See, let's take left hand side, cos of 18 degree minus sine of 18 degree. Now remember, we have formula for sin C plus sin D, sin C minus sin D, cos C plus cos D, and cos C minus cos D. We do not have any formula in the shape of cos C minus sin D or either sin C minus cos D. So first of all, we have to first transform this sin 18 degree to something cos. That is, let's try. We know that sine of 18 degree can be written as sine of 90 degree minus 72 degree. Sine of 18 degree, this can be written as sine of 90 degree minus 72 degree. Now we know that sine of 90 minus theta is cos of theta. So therefore this is cos of 72 degree. So our statement is now cos of 18 degree minus this sine 18 is cos of 72 degree. Yes, now we can use cos C minus cos D. So it is 2 sine 18 degree plus 72 degree by 2 and sine D minus C, which is 18 degree. So 72 degree minus 18 degree by 2. So this is 2. Now 18 degree plus 72 degree, it is 90 degree, and divided by 2, hence it is 45 degree. And sine 72 minus 18 degree, it is sine 54 degree. 54 divided by 2, which is 27 degree. So it is 2, and we know that sine of 45 degree is 1 over under root 2. So it is multiplied by 1 over under root 2 sine 27 degree. So we have now 2 divided by under root 2 sine 27 degree. Let's change into right hand side by multiply and divide by under root 2. Here this 2 get cancelled with this under root 2 into under root 2. So we have under root 2 sine of 27 degree, which is required right hand side. Now let's try another example. Show that sine of 5a minus sine of 3a upon cos of 5a plus cos of 3a. Now this is equal to tangent of a. Now sine of 5a minus sine of 3a upon cos of 5a plus cos of 3a. This is simply a case of sine C minus sine D cos C plus cos D. So this is sine C minus sine D, which is 2 cos C plus D by 2 sine C minus D by 2 divided by 2 cos 5a plus 3a by 2 cos 5a minus 3a by 2. So 2 get cancelled with 2. So this is cos of 8a divided by 2 sine of 2a divided by cos of 8a divided by 2 cos of 2a divided by 2. So this is simply 2. This is simply sin a upon cos a, and this is tangent of a, which is your required right hand side. Right. Now next is cos of alpha plus cos of beta whole square plus sine of alpha plus sine of beta whole square. Show that this left hand side is equal to 4 cos square alpha minus beta by 2. 4 cos square alpha minus beta by 2. Now, first is take left hand side, cos of alpha plus cos of beta whole square plus sine of alpha plus sine of beta whole square. Now we know that this is simply cos C plus cos D, and this is sin C plus sin D. So cos C plus cos D is actually two times cos of C plus D by 2 cos of C minus D by 2 square plus sine of C plus D 2 sine C plus D by 2 sine C minus D by 2. So using these two equalities, we have cos of alpha plus beta by 2 cos of alpha minus beta by 2 whole square plus sine of alpha minus beta by plus by 2 sine cos of alpha minus beta by 2 whole square. So this is 4 times cos square alpha plus beta by 2 on cos square alpha minus beta by 2 plus 4 sin square alpha plus beta by 2 cos square alpha minus beta by 2. Now you see we have common cos square alpha plus beta by 2. Now we have common cos square alpha minus beta by 2. This is cos square alpha plus beta by. So take this cos square alpha minus beta by 2 outside. Of course 4 also take outside. It is 4 cos square alpha minus beta by 2. See this. We have with cos square alpha plus beta by 2 and sin square alpha plus beta by 2 plus, this is common, and we have cos square alpha plus beta by 2 plus sin square alpha plus beta by 2. And we know this identity, basic identity, cos square theta plus sin square theta is equal to 1. So you will get cos square alpha minus beta by 2, and this is your required right hand side, right? Now next